Tonight's presentation titled How Risky is Maintenance? And our presenter is Mike Bush. Mike is president of Savvy Aviation Incorporated. He's an author for numerous aviation publications, holds a certified flight instructor certificate, A&P mechanic certificate with inspection authorization privilege, Aviation Maintenance Technician of the Year with the FAA in 2008, and a member of EAA. Mike, thank you so much for being with us. I'm going to turn control of the presentation over to you.
Smoothly. Anyway, we're going to talk a little bit about the risks involved in GA maintenance. This is a subject, of course, that I've been talking about for a long time, and I've been preaching maintenance minimalism, doing only the maintenance that is demonstrably necessary, and talking about the risk of doing particularly invasive maintenance like cylinder replacements and things like that because of the risk of maintenance-induced failures. But the question, of course, always comes up with just how risky is maintenance? How often do maintenance-involved failures occur? How often do they cause accidents? How serious are the consequences? And there have been a lot of studies on this, and over the years I've sort of wet my finger, stuck it up in the air, kind of averaged all the things that I've read, and come up with the following sort of general breakdown that accidents are roughly 75% caused by the pilot, about 12.5%, about 1/8 caused by the machine, and about another 1/8 caused by something that a mechanic did or failed to do that caused the accident. These are kind of very rough ballpark numbers that I've sort of come up with over the years. But I was cleaning my office the other day, and I ran across an old study. It was actually published in 2002. That the FAA, a group of FAA people down in Oklahoma City did, that related to this question of just how risky maintenance is in general aviation and what the consequences of maintenance failures are. And this group of FAA analysts analyzed 10 years worth of NTSB accident reports involving general aviation accidents in the decade 1988 to 1997. It was some time ago, but not a whole lot's changed since then, and so the things that they came up with are still pretty valid today, I think. But they looked at NTSB accident reports that had at least one maintenance-related issue listed as either the probable cause of the accident or a contributing factor to the accident. And what they found during that 10-year period of 1988 to 1997 was that there were a total of 20,884 general aviation accidents, and that 7.1% of those, 1,474 of those accidents, reported at least one maintenance-related error as the primary cause or a contributing factor to the accident. So keep that number in mind, 7.1%. That's a little lower than the 12.5% ballpark number that I usually quote, but we'll talk about that in a bit. But at any rate, of those maintenance-involved accidents, of those 1,474 accidents over 10 years, which would be like 147 or 148 accidents per year, 18% of them involved fatalities. And of course, a lot of accidents that there are more than one fatality during the accident. And in this 10-year period, there were 504 fatalities attributed to accidents that were maintenance related. So something like 50 fatalities per year. So it's pretty significant. of those maintenance-induced accidents, 86% involved airplanes, 12% involved helicopters, 2% involved other kinds of aircraft, lighter than air, and gliders and stuff like that. And that actually is a little bit interesting because a whole lot more than 86% of the accidents of the fleet were airplanes. So it turned out the helicopters actually had a significantly higher maintenance risk because helicopters are just inherently more maintenance intensive than airplanes are. Now, one of the peculiar things about this study, and something that sort of affected the outcome of the study, I think, and the FAA analysts thought as well, was the fact that the NTSB has this very puzzling way of categorizing maintenance-related accident causes. They have a taxonomy that consists of this set of categories, and so that when they report on an accident and they think that it has some sort of a maintenance component to it, they will classify the maintenance component as one or more of these categories. The thing that's strange about it is that these categories are a bit puzzling. For example, there's a category called design change, but there's another category called major alteration. And it's not exactly clear what the difference between a design change and a major alteration is. There's category of annual inspection and there's a category of maintenance inspection. Well, I'm not exactly sure what a maintenance inspection is. Is some inspection other than an annual, or it's a little unclear. There's a category that's just called maintenance, which sounds like maybe some sort of a catch-all category that they throw stuff in when they can't figure out anything else to categorize. But it's a bit strange. And finally, there's a category called servicing. Well, servicing is normally not even considered maintenance. Servicing is usually things like fueling an airplane, or putting air in the tires, things like that normally are not considered to be maintenance, and they don't require logbook entries and so on. And so it's a little strange why they would have servicing on this list. But at any rate, it is a puzzling way of categorizing things, and it probably affected the outcome of this study. But at any rate, the FAA was sort of stuck analyzing the accidents based on the way the NTSB categorized them. And when it looked at that categorization, the highest the most frequent category for maintenance related accidents was the category called installation. Installation was cited in 20% of the maintenance related accidents. The two inspection categories came next: maintenance inspection, whatever exactly that is, an annual inspection, which I guess we sort of know what that is. At 14 and 8%. So the two inspection categories combined came to I guess a category called maintenance, and then all of those other categories that were listed came in at under 5%. So because installation cited category of maintenance error in these accidents, the FAA analysts drilled down a little bit in this installation area to see what they could find out about it. And it turned out that these accidents that were attributed to installation errors were not only the most frequent cause of accidents, but they also had the most severe consequences, with 59% of the accidents attributed to installation errors resulting in injuries, fatalities, or both. Here's an example of a accident that was classified as an installation error. It used to be a Cirrus SR-22. It pretty obviously was a fatal accident. It was caused by a mechanic forgetting to tighten an AN cap in the fuel system. And so while in flight, the cap came loose, the engine lost fuel pressure, and you can see you can see what the result was. It was pretty severe. But in any case, the NTSB categorized this as an installation error accident. So I suppose the installation of the AN cap. When they looked at the different parts of the airplane that were involved in these installation error accidents, the most frequent by far was power plant, with 56% of the installation error accidents involving power plant. And although they don't say this, the information really isn't available, my guess is that a big part of those power plant installation accidents involved installation of cylinders, because that's the most commonly invasive kind of installation that gets done on power plants. Flight controls came in next at 13%, landing gear at 10%, rotor system on rotorcraft came in at 10%, and electrical at 5%. So that has to do with how frequently these various parts of the aircraft were involved in installation-related maintenance-induced failures. And again, power plant came in as the leader. Then they classified the types of installation errors. And again, I'm not sure this gave a great deal of insight, but the way the NTSB categorized this is 29% were incorrect attachment, 22% were incorrect connection, 22% were omissions, 17% wrong part installed, and 10% part installed backwards, which is sort of interesting. When we look at the consequences of installation errors, 86% of those accidents involved an emergency forced landing someplace other than an airport, and 2/3 of those emergency landings resulted in injuries, fatalities, or both. Only 14% of the accidents involving installation errors either got back to the departure airport or made it to the destination. So if you have an installation error related accident, you're very likely to wind up off airport and very likely to get hurt. When they look at the likelihood of injury of death and these various things, it was interesting and a little surprising, I think. The likelihood of injury or death in an electrical maintenance-induced failure was 73%. I wouldn't have guessed that electrical would be near the top. I would have guessed things like flight controls would be near the top, but apparently there must have been, electrical fires or electrical failures at night or something that was pretty severe to cause these accidents that involved injury or death. But right behind electrical were flight controls, which you sort of expect that an error in installing flight controls is likely to be pretty serious. Power plant came in right behind that at 62%, and improper installation of the rotor system on rotorcraft came in at 52%. After looking at all of this stuff and crunching all these numbers, the FAA analysts, the end of this report involved a discussion section in which the FAA analysts tried to make sense of all these numbers, and they sort of came to the conclusion that the risk involved in GA maintenance was probably greater than this analysis of the NTSB data showed. They noted that this 7.1% figure, which was the number of GA accidents that the NTSB attributed to maintenance errors, was much lower than most of the other studies that have been done in this area, many of which found the rate to be closer to 20%. And the FAA attributed this to NTSB's rather peculiar methodology of codifying aircraft accident causes and contributing factors, that taxonomy we were looking at before, in a way that the FAA analysts felt often failed to assign a maintenance reduced related code to accidents that actually were maintenance related. So the FAA analysts felt that the NTSB's weird coding method resulted in underreporting of maintenance-induced failures in the accident. And again, quoting from the FAA analysts, as a result, there are probably many more maintenance-related reports in the NTSB database that were not included in the study because they were not designated with a maintenance code. Again, while I mentioned this earlier, while helicopters comprise only 3% of the GA fleet, they were involved in 12.4% of the maintenance-related accidents because helicopters are inherently more maintenance intensive than airplanes. And so the rate of maintenance error is likely to be much higher just because there's a lot more maintenance done. So there's going to be a lot more errors. But the study indicated that the kinds of maintenance errors made on helicopters was not very different than the kinds that afflicted airplanes. It was just that helicopters got so much more maintenance that the incidence of error was higher. As we saw, the single most frequent cause of maintenance-related accidents were installation errors involving the power plant. And I've talked many times about the risk of cylinder work in the field and the fact that I feel that most A&Ps don't have an appropriate level of fear, if you will, when it comes to installing cylinders, because it is risky business. The FAA said it more diplomatically than I usually say it, but they said it seems reasonable to develop guidance to aid maintainers on the inherent risks of maintaining various general aviation aircraft. These guidelines could be empirically developed, informed by accident and event data. Translating that into plain English, the FAA analyst felt that analysis of what sort of maintenance-induced errors occur and what their consequences are ought to be fed back to mechanics so that mechanics have a better understanding of the risks involved in the stuff that they do. The fact that they do it every day tends to make them very complacent about it. Mechanics change a lot of cylinders, and so they don't think all that much about the fact that changing cylinders are risky business. And there really isn't any guidance to mechanics right now that indicates to them just how risky it is, or to aircraft owners for that matter. And the FAA analysts who wrote this report felt that there ought to be. Then there was an interesting discussion at the end of the report, which I am titling "Will A&Ps Confess Their Sins?" The issue there that the FAA analyst brought up was the fact that our current GA maintenance culture is rather unlike, for example, the pilot culture. Pilots tend to talk about accident causes all the time. We tend to be accident report junkies. We read about aircraft accidents. We talk about aircraft accidents. We because we feel like the more transparency we give this subject, the better we are going to be prepared to deal with problems when they occur to us. The maintenance culture seems to be quite different than that. They don't talk about maintenance-induced failures. It's not a subject that really is ever talked about among mechanics. And to quote the FAA analysts, nearly every mechanical failure is investigated and archived so that the failure rate of a specific type of component can be analyzed and precisely tracked. This is talking about failures of the machine. The, we have SDRs, we have ADs that get issued. When machines fail, there's a lot of remedial action that takes place. A lot of attention is paid to it. But the FAA analysts go on to say, however, the same investigative and analytical resources are not applied to cases of human error in the maintenance shop. Talking about the maintenance-induced failures. A major obstacle to 100% error reporting in maintenance is the punitive work environment so pervasive industry-wide. AMTs may hesitate to report their errors for fear of reprisal from management or government. Kind of interesting. And they go on to say, therefore, any maintenance error reporting system will likely require some level of immunity to disciplinary action in order to be successful. Now, we already have a system that provides some level of immunity to disciplinary action, and it's called the Aviation Safety Reporting System. And pilots file ASRSs all the time, and we're reports all the time, and we're sort of trained that when we screw up, one of the first things we do is file an ASRS report because unless it was an intentional error, if it was an inadvertent one, filing a timely ASRS report gives us sanction immunity from the mistake that we made. And so pilots are pretty spring-loaded to file these reports. Mechanics can file ASRS reports too, but they don't do it very often. And of course, one of the problems with ASRS reports is that although it provides us immunity from sanction by the FAA, it doesn't provide protection from sanctions from the employer. So if a mechanic is worried about being violated by the FAA, an ASRS report would help. But if he's worried about getting fired, an ASRS report is not going to help that. And it turns out that ASRS reports are very rarely filed by mechanics. The recent count in the ASRS database contains 172,000 reports by flight crew members, 24,000 reports by air traffic controllers, only 6,000 reports by maintenance technicians. And I would be willing to bet you dollars to donuts that the vast majority of those 6,000 reports by maintenance technicians came from mechanics in the airline industry, not general aviation mechanics. It's just very, very rare that a GA mechanic will file an ASRS report. So it's really not a system that is used by them or that provides the kind of immunity that they would need to be, honestly, admitting to their mistakes. So that report was done almost 20 years ago. Where are we now? Well, GA maintenance is still considerably riskier than most pilots, mechanics, and aircraft owners believe. It's not a subject that's talked about enough. It's a subject that I try to talk about a lot because I think it's a much more serious problem than the attention that it's getting. Not much change has changed since the FAA wrote this report. And we as aircraft owners are the last line of defense against maintenance-induced failures. So we have to take our responsibility there quite seriously. What can aircraft owners do? Well, one thing we can do is say no to risky or invasive maintenance unless it's absolutely unavoidable. If a mechanic says we need to change a cylinder, you should be asking a lot of questions before you agree to having him change a cylinder. Because it's like, if a doctor says we're going to have to do an open surgical procedure on you, it would be very smart to ask a lot of questions about it and about what the risks are, maybe get a second opinion, because surgery is inherently risky. and it's not something we want to do unless there's a really compelling reason to do it. And if it turns out that it's necessary, we should be hiring the most experienced and talented specialists to do this risky work that we possibly can. A lot of this risky work really shouldn't be done by your your typical A&P mechanic in the field. It should be done by somebody who specializes in this work. So if it's taking an engine apart, it would be really nice if it was an engine specialist who was doing it. And finally, aircraft owners should always be religious about doing a post-maintenance test flight before carrying passengers or making cross-country flights, particularly in IMC or over rough terrain. And owners have to understand that the first flight or few flights after maintenance, particularly if it's invasive maintenance, is the most likely time that the airplane is going to have a mechanical failure. So it always drives me nuts when one of my clients gets his airplane out of a heavy annual and proceeds to load his wife, his kid, and his dog onto the plane and fly off to the Bahamas without doing one or two very serious post-maintenance test flights. You can bet that I do post-maintenance test flights on my airplane after every maintenance event before I, carry family members or, my fiance or whatever. And I do my own maintenance, and I have a lot of faith in my own abilities to do good maintenance. But every mechanic, even the best mechanics, make mistakes. We're human, and the post-maintenance test flight is sort of your last line of defense against those failures. So, and I have done a webinar specifically on that subject of the post-maintenance test flight and what we should go through. So, Tim, that's all the material I have, but hopefully this is interesting enough that maybe we can have some discussion about it.
All right, Mike. Yes, very much so. We got many questions already so far. Let's jump in first. Jesse just wanted to know, what's an AN cap?
Oh, well, the fuel fittings on most aircraft are AN fittings that are where lines and hoses connect together. There'll be T fittings and various things, and a cap is simply something that caps off uh, a port in an AN port in a fuel system, and frequently there are ports like that you open to connect, say, a gauge for adjusting the fuel system or something, and then when you're done making that adjustment, you disconnect the gauge and you cap off the port with an AN cap. And of course, if that cap comes off, then fuel's going to start escaping out of the system, and that's not going to be a good thing. So that's apparently what happened in the case of the Cirrus crash. I don't really know a lot of the details about that Cirrus crash, except that the NTSB report indicated that an AN cap came loose, and it was shortly after maintenance that involved the fuel system.
Drew comments that there was a recent Piper wing spar AD that now calls out reinstallation of a chamfered washer being an issue.
Mm-hmm. Maybe that's one of those installed it backwards cases that they were talking about. I'm not sure.
Sounds like it. Bill wondering, can you advise why this is so risky? Is it just the technique used, or incorrect torque, or what is it?
Oh, if he's talking about cylinders, that's a very rich subject, and I've done a full webinar on it and published several articles on that subject. It's probably more than we can really get into here in the Q&A, but there are a lot of ways to screw up cylinder installation. There's a lot of very, very critical things that have to be exactly right. The mating surfaces have to be scrupulously clean. The fasteners have to be thoroughly lubricated before fasteners are torqued on. The torquing needs to be performed in exactly the right way. And there's just a lot of ways that, to screw it up, and there's been a lot of very serious accidents caused by failures shortly after cylinder installation. In fact, I am just involved as an expert witness on one of those right now, and I've been involved as an expert witness on a number of aircraft cases in the past related to a catastrophic engine failure shortly after cylinder installation. So I'm sort of acutely tuned into the risks involved.
Dwayne wonders, has there been any studies comparing maintenance error rates for Part 145 repair stations and Part 65 maintenance shops?
That's a really great question. I don't know the answer. This particular study did not address that at all. And I'm not sure whether that information could be easily derived from the NTSB accident database or not. But that's a very good question. You know, certainly Part 145 shops receive a lot more scrutiny from the FAA, and the regs require much more training of technicians who work in Part 145 shops than those who work in Part 65 shops. But I'm not aware that anybody's ever actually done a rigorous study of the comparative rates of maintenance-related accidents. That's a really excellent question, though.
John wonders, so would ASRS reporting protect from liability suit?
No. The ASRS reporting, filing a timely ASRS report gives immunity only from FAA sanction. In other words, if you file a timely ASRS report, the FAA cannot take a certificate action against you or fine you if the error. There are certain exceptions. It doesn't provide immunity if it's an intentional error. It doesn't provide immunity if it's an error that involves criminal activity. But most of the time, filing a timely ASRS report gives you sanction immunity from the FAA. But it doesn't immunize you from anything else. It doesn't immunize you from being sued. Doesn't immunize you from being fired. It only is immunity from FAA sanction.
Michael's wondering, are NASA reports the same as ASRS reports?
Yes, exactly the same. NASA, the aviation safety reporting system is a function that is administered by NASA, and the two are synonymous. Yes.
John wonders, are the statistics different for piston versus turboprop maintenance?
Again, I'm not sure of what the answer to that is. I would suspect, for example, that the number of power plant maintenance-induced failures would be less for turbine aircraft because turbine aircraft undergo far less power plant maintenance and far less invasive power plant maintenance than piston aircraft do. But that's just a suspicion on my part. I don't know that there's ever been a rigorous study of that.
John wonders, do the GA maintenance errors occur predominantly in small shops with perhaps only one or two mechanics? And what might be the risk, a greater or lesser of owner-assisted versus A&PIA doing all the work?
Well, again, to the first question, I don't know the answer. I don't think that that's really ever been studied. I have a feeling that the risk has a lot more to do with the experience and subject matter expertise of the person doing that particular work than who he's employed by. But that's just my suspicion. With regard to owner-assisted maintenance, again, I'm sure that's not a subject that's ever been studied. My suspicion is that there are less errors made when the owner is involved, because owners tend to be very highly motivated to double and triple check everything. I'm saying this as somebody who went through that process myself, starting out as being an aircraft owner who was basically an appliance operator, then gradually getting into owner-assisted maintenance on my aircraft, and ultimately going all the way to becoming an A&P and an IA. So I remember distinctly all of those phases of my uh, of my trajectory, if you will. And uh, one of the things I personally found out when I started doing maintenance on my own airplane, and this is long before I was an A&P myself, so it was maintenance under supervision, but the number of maintenance-induced errors went down dramatically when I started doing the work myself. And it wasn't because I was a good mechanic, because I was a very rookie mechanic. It was because I was very highly motivated, and because I was pretty terrified of the whole thing. And so I double and triple checked everything and did everything exactly according to the manual, and all the things that you would sort of expect a novice mechanic who was then going to be flying that airplane after the work was done would do. So again, I'm just giving you my own personal opinion on that. I can't really give you any study results, but I think I think airplanes that have maintenance involved owners are among the best maintained airplanes that there are.
Mm-hmm. And Merrick's comment, he says, I wonder how often the mechanic at a small shop has the opportunity to invite another set of eyes to check his work.
That's a huge problem, and that is a really big deal, I think. If you go to an aircraft factory, or you go to a big uh, service center like a Cessna Citation Service Center, um, three sets of eyes typically look at everything that's done. Typically, there are two AMTs working as a team and cross-checking one another's work. And then when they get all done, an inspector comes in and he checks the work. And the inspector works for a different department than the AMTs, and he's not even allowed to go have lunch with them. Um, so a lot of eyes look at everything in airplane factories and in big maintenance operations like a Citation Service Center, a Gulfstream Service Center. In the typical GA maintenance shop, typically the only set of eyes that ever sees the work is the set of eyes connected to the hands that did the work. And I do think that's a very big problem.
Carl says, pilots use checklists to ensure nothing important gets forgotten. Are there AMT checklists for routine GA maintenance procedures to prevent things like the AN cap mishap?
Well, yeah, there certainly are. And those checklists are called maintenance manuals. And theoretically, a mechanic is not allowed to do maintenance unless he has the maintenance manual. Um, and the maintenance manuals normally go through step by step by step instructions on how to do things, although some maintenance manuals are better than others. Um, the other side of the coin is, if you just hang around maintenance shops and watch mechanics work, it's amazing how seldom you see them refer to the maintenance manual. They will typically refer to the maintenance manual if they're doing something that they don't do very often. But when they're doing stuff that they do a lot, like for example, changing cylinders, they almost never refer to the maintenance manual because they figure they know they know how to do this. They've done it a million times, and of course, you know, you can obviously see the pitfalls in that, and that's why I as a novice, uncertificated mechanic who was swinging wrenches on my own airplane under supervision. I was the guy who was always had his nose in the maintenance manual because I didn't know what the heck I was doing, and so I was very religious about following the maintenance manual step by step. But the more experienced you get, the less often you look at the manual. At least that's my that's been my observation. I've spent a lot of hours hanging around maintenance shops watching mechanics work, and that's kind of the impression that I have.
Dave says a lot of GA maintenance shops today have signs forbidding anyone but an employee to enter the workshop part of the hangar, usually attributed to insurance risk management. Any tips on how to work out owner-assisted maintenance with shops like that?
It's a big problem, and to be honest with you, I think that insurance almost never has anything to do with that. Now to be fair, um, shops that are Part 145 repair stations um, have pretty serious regulatory restrictions on who's allowed to swing wrenches on airplanes, um, and it's just about impossible to do owner assisted work at a Part 145 shop because the Part 145 shop has requirements that anybody that swings wrenches in that shop has to be approved by the FAA, has to go through some requisite training, all that kind of stuff. None of those requirements apply to Part 65 shops, which are the non-repair stations. So if you're looking to do owner-assisted work, and that's how I got into maintenance, and I certainly encourage every aircraft owner to do that. You have a much better chance of accomplishing that working with a Part 65 shop or with an individual A&P than you would working in a repair station. Repair stations really aren't allowed to have strangers working on airplanes under their roof. Now, there are also Part 65 shops that just don't like owners hanging around because they're pain in the neck, and they clearly if an owner is involved in maintenance, it doesn't usually speed things up. It slows things down because the mechanics are spending a lot of time teaching the owners what to do and making sure they do it right, all that stuff. And so there are some shops, even ones that are not forbidden from doing it by regulation, that just don't like to do it because they don't like to do it. So it is becoming harder and harder for owners to find shops or mechanics that are willing to let them get involved in supervised maintenance. And I think that's a shame, but it is it's a fact of life. So owners just have to work harder to find the right situation if they want to do that.
Chuck wonders, are records of violations, sanctions of mechanics, and/or shops available to pilots for review as a means of vetting a new shop before using?
Absolutely not. No, they are not. That information is pretty seriously protected.
And William is wondering, is there any option for owner-reported service difficulties or maintainer-reported component installation issues?
Well, I didn't really understand the last part of the question. Certainly, anybody can submit a service difficulty report to the FAA. It doesn't have to be a mechanic. And you can do it online nowadays. The SDR form is available online. And theoretically, SDRs are reviewed by somebody, and if there are enough of them that reveal the same sort of problem happening, then that somebody is supposed to, somebody in the FAA, I mean, is supposed to do something about it. The system is very flawed. The SDR system. It's very, very rare for a Part 65 shop to file SDRs because they really don't have any incentive to do so, and it's time consuming. Part 145 repair stations are theoretically required to submit SDRs, but it's amazing how infrequently they do. And I don't think there's a great deal of faith among mechanics that when they file an SDR, anything comes of it. So the SDR system could definitely use an overhaul, both in terms of who's required to file them, and also some sort of an incentive system to make it worth people's while to file them, because it really is very important to get that feedback funneled into a database someplace, so that if problems are happening repetitively, it comes to somebody's notice and something can be done about it. But it is a system that I think everybody realizes is pretty seriously flawed right now.
Yeah, Jerry comments, if a mechanic repairs an aircraft, how would she know if they repaired the engine incorrectly? Seems like the system being talked about does nothing to prevent a problem from happening, only after the fact remedial training, plus they open themselves up to punitive damages.
Well, I mean, I guess the answer to how a mechanic would find out that he made an error is that if he made a small error, the aircraft owner is probably going to come back to him and be pretty angry. If he made a big error, the FAA is probably going to come back to him because when there's an accident, one of the first things that happens is they look to see who's the last person who worked on the airplane. So if mechanics make serious mistakes, they're going to find out that they made the mistakes, but they're going to find out usually after something bad happens.
Frankie wonders, might manufacturers' inspection procedures and manuals need a regular refreshing to take this kind of data into consideration? And is that feedback loop happening enough?
The answer to the first question is yes, and the answer to the second question is no, not at all.
And Carol wonders, when a shop IA signs off on an annual for a crew A&P, aren't they required to inspect what they're certifying was done correctly?
I didn't understand the phrase crew A&P exactly, but
I think what she means just an A&P doing the work and then the IA coming around later to inspect what the work was done by, some other A&P they're supervising.
Well,
I think is what she meant.
That's not typically the way it works. IAs are only involved in doing inspections required by regulation, which for most of us is the annual inspection. IAs don't get involved in repairs. Now, every IA is also an A&P, so it's fairly common for an IA to inspect something, find something wrong, then remove his IA hat, put on his A&P hat, and go repair something that was wrong, and then put his IA hat back on and inspect it and say, oh, miracle of miracles, the problem has magically gone away. I can sign off this airplane as airworthy. That's the way it normally works. That doesn't, that doesn't mean that there was more than one set of eyes involved, because frequently there wasn't. But IAs are I you know you, IAs are not supervisors. IAs are inspectors, um, and the the person doing work is the person who signs the logbook entry. So if a mechanic makes a repair, that mechanic signs off a logbook entry that memorializes that repair. And his signature on the logbook entry denotes that he performed the repair in a satisfactory fashion. There's another kind of logbook entry for inspections that are typically signed off by IAs. The IA has to do the inspection personally. That's not something that can be delegated. And then the IA makes an airworthiness determination as to whether the aircraft is airworthy or not. And either way, he makes a logbook entry and signs it. And if the logbook entry says that he's determined that the aircraft is airworthy, then his signature means that he's inspected the aircraft and found it airworthy. If it says that he found it unairworthy, then he is required to make a list of the things that he found that were unairworthy and give it to the aircraft owner. That list doesn't appear in the logbook entry. Logbook entry simply says, I found the aircraft unairworthy and I gave a list of the discrepancies to the owner, and then the mechanic, then the IA signs that entry. And the list of discrepancies is a separate document that's given to that's signed by the IA and given to the aircraft owner. I don't know if that answered the question or not.
Okay. Michael wonders, are there any pros, cons worth noting in regards to an owner getting an A&P certification to do their own maintenance work?
Well, I mean, I did that, but it's not easy. The FAA does not make it easy to become an A&P. I wish they had some sort of limited repairman certificate, let's call it, or something, that the owner of a certificated aircraft who wants to work on his own aircraft could get, uh, you know, in a reasonable amount of effort and with a reasonable amount of training. But no such thing exists, and there doesn't seem to be any appetite within the FAA for anything like that. So to get an A&P, you first of all have to have be able to document a very large amount of experience. It's 30 months of full-time experience, or if you're doing it part-time, which most owners would do it part-time, it would come to 4,800 hours of part-time experience. Now that's a lot of time. It took me 10 years to accumulate that much experience doing stuff part-time. And if you think about it, to get an ATP requires 1,200 hours of experience. To get an ANP requires 4,800 hours. What's wrong with this picture? That's a big number. And and then you have to convince an FAA inspector to sign off your form. Then you have to take 3 separate written exams, knowledge tests, and a practical test, which is effectively the check ride that usually takes at least a whole day. And that's what's involved in getting an A&P. And getting an IA requires getting an A&P first, being an A&P for at least 3 years, and then meeting a bunch of other requirements and taking another test. So it's not easy. It's quite hard for aircraft owners who are doing this part-time and have a day job to accomplish. And I think it's unreasonably difficult. And I wish the FAA would come up with something that, that was more appropriate for an aircraft owner who really only wants to work on his own airplane. He doesn't want to hang up a shingle and do it as a business. But there is the FAA doesn't have any such thing either in existence or in the works, unfortunately.
Barrett wonders if there's any data comparing maintenance-induced accidents versus accidents where required maintenance was not performed. Can we assess the risk of unmitigated maintenance errors versus choice to trust luck?
Well, I'm not really sure I understand. So first of all, a lot of maintenance-related accidents, a lot of maintenance-induced failures are failures of omission rather than commission. That is, that the mechanic didn't do something he should have done, as opposed to the mechanic did something wrong. But I think that that's probably not what the questioner really meant by that. The question was really what is the what is the risk of a minimalistic maintenance philosophy? And actually, the answer to that is that there is a very, very rich body of research that has been done into that, and there are big textbooks and stuff on that subject that are typically titled reliability centered maintenance, because that's what reliability centered maintenance is all about, is determining exactly what the optimum amount of maintenance is that provides the necessary level of reliability with the minimum amount of cost and the minimum amount of risk. And there's been a tremendous amount of engineering research done on that over a very long period of time. And that's really the essence of the maintenance philosophy that I often refer to as maintenance minimalism, but I also often refer to it as reliability centered maintenance, which is the name that the guys who sort of came up with this concept at United Airlines back in the 60s, they coined the term reliability centered maintenance. But there's a tremendous amount of work been done on that. A lot of stuff, a lot of textbooks and stuff on the subject, and some very good data.
James says that general aviation pilots are required to have a flight review at least every 2 years. Are mechanics required by regulations to acquire periodic training?
They are not, and that was one of the things that when I became a mechanic after many years of being a pilot, I found positively scandalous. But there is no such thing there's no such equivalent as a flight review for a mechanic. Mechanics, there is no requirement for recurrent training for mechanics. Basically, once they get their ticket, they're good to go indefinitely. And as a result, there's an awful lot of very stale knowledge within the mechanic community. I mean, some mechanics are information junkies and they like to stay on the bleeding edge of things, but an awful lot of mechanics aren't. And the FAA doesn't require any recurrent training. As an IA, I have to renew my IA certificate every 2 years, much like my flight instructor certificate. It has to be reinstated every 2 years. And there are a couple of different ways for an IA to do that. He can do that by signing off a certain number of annual inspections during that 2-year period, for example, or he can do it by going through a recurrent training course every year that qualifies him to renew his IA certificate. So IAs are required to do a certain amount of recurrent training, but A&Ps who are not IAs have no requirement at all to do recurrent training. And I think that's wrong.
Leonardus is wondering, given the relative high risk of maintenance, should we move to biannual inspections instead of annually? Is there any talk about this by the FAA?
There's no talk about it by the FAA, and thank goodness there isn't, because it would be a terrible idea. Um, uh, Personally, I think annual inspections uh, are way overkill. Unfortunately, that's what the regs require, so that's what we have to do. There are some things in airplanes that ought to be inspected more than once a year. Pretty much anything having to do with the power plant really should be inspected more often than once a year. There are a lot of things in airplanes that don't need to be inspected as often as once a year. And when you get into big airplanes, they have phase inspections uh, where things that need to be inspected more often get inspected more often, and things that don't need to be inspected that often don't get inspected that often. But in our little airplanes, we have this concept of an annual inspection, which basically says everything has to be inspected once a year, which is sort of a very crude one-size-fits-all solution, which doesn't really make a lot of sense. But it's what we're stuck with. That's what's in the regulations. But it's certainly not the best way of doing it. I certainly would not be in favor of any regulation that required inspecting more often than once a year. I would be in favor of making it possible for owners to use some sort of phase inspection program on their little airplanes, much like what's done on big airplanes, so that the things that don't have to be opened up and closed, as often as every year, don't get open and closed that much, because we actually do a fair amount of damage to our airplanes by opening up, inspecting them, and closing them every year. And a lot of that is unnecessary. Um, some of it is necessary, and some of it isn't often enough. But we're stuck with this, inspect everything once a year concept for small planes, and so that's kind of what we're stuck with.
David says on my annual on my Aero, the mechanic would remove the injectors to clean them on every annual first flight. After that, I'd have a plugged injector at least once. After I started to instruct them not to do that and didn't have any more problems with plugged injectors on test flights. Was I wrong in doing this?
No, in fact, your experience is precisely the same as my experience. The only time I have ever had problems with injectors is right after they got removed, and so I stopped doing it many years ago, because it's just one of those maintenance things that does more harm than good. I have an engine monitor. If an injector gets clogged, I can tell. I don't have to, be cleaning my injectors once a year. I can clean an injector if and only if something is demonstrably wrong with it, and that almost never happens, because the way injectors typically get clogged is somebody opens up the fuel system and some foreign material gets inside while the fuel system is opened up, and it works its way all the way down to the smallest possible orifice, which is that's the one in the fuel nozzle, and it gets stuck there. So no, you did exactly the right thing by telling your mechanics not to do that, and I stopped doing that years ago.
All right, so Dwayne's question here, it's like the granddaddy of all questions here
Okay.
related to your presentation. What's the most risky maintenance work? Question mark.
Well, I mean, generically, the risk of maintenance is proportional to the invasiveness of maintenance. And probably the most invasive maintenance that tends to be done in the field on a routine basis is cylinder replacement. So that's why I've sort of been on this campaign to recognize that cylinder replacement is risky, to not do it unless it is absolutely necessary, and when it's absolutely necessary, make sure it's done by the most experienced person in doing that kind of work that you can find. Because there are an awful lot of ways to screw it up, and there have been an awful lot of accidents caused by screwing it up.
And Jim wonders, my 0300 engine has an annoying small oil leak coming from one of the through bolts in the front of the engine. I suspect it's a small O-ring on the through bolt. Is this something a specialist should repair, or can a generalist change out that O-ring?
Did he say it was an 0360?
0300, so it must be Continental
0300.
0300.
Oh, Continental. Okay, because Lycoming through bolts don't use O-rings, but Continental through bolts do. And it is possible to change out a Continental through bolt. It is not easy to do, especially if it's been sitting there for a long time. And so it is the kind of thing I would definitely recommend having an engine shop do if at all possible. And there are quite a number of engine shops that are on airport locations where you can just fly in there and they can work on your engine and don't have to pull it out of the airplane, ship it off to them. So you would definitely want to pick an engine shop that was like that was on airport and could work on your engine while it was still in the airplane.
David wonders if you could comment on the secret study during World War II by Waddington, how unnecessary maintenance caused problems.
Well, yeah, there's actually an article that I did for EA Sport Aviation back, oh wow, probably back around 2010 on that subject. But it was very, very interesting. There was a group of scientists who got drafted into the RAF during World War II, and were tasked with providing engineering advice to the Royal Air Force. And the guy who was heading up this group was a geneticist, as it turns out, named C.H. Waddington, who didn't know anything about airplanes or maintenance, didn't really care anything about airplanes or maintenance. He was a geneticist, but like a lot of people back then, he got pulled into the war effort. And so he and the scientists who worked for him applied their scientific method to analyzing lots of stuff for the RAF, all sorts of interesting stuff, like what's the optimum depth that a depth charge should go off to maximize the kill ratio on German submarines and things like that, or what's the optimum color to paint an aircraft that's dropping those depth charges so that the submarines can't spot them with their periscopes. And they did all sorts of studies like that. But one of the things that they were asked to do is look at the way these airplanes were maintained. And so they crunched a lot of numbers about squawks and maintenance failures and all sorts of stuff. And they came to the conclusion that these airplanes were spending way too much time in the maintenance hangar because way too much maintenance was being done for their own good. And the what we would nowadays call the force readiness was way lower than it could be if the maintenance was simply cut down to the minimum that was really necessary. And so they stopped doing an awful lot of the preventive maintenance that they had been doing before, and they lengthened the preventive maintenance intervals for a lot of other stuff. And the force readiness of that fleet went up absolutely dramatically. And all of this stuff was classified and didn't actually become known until almost, I guess it was something like 1978, long after Waddington's death, when his notebook was declassified. And it was fascinating. It was a fascinating study that they did that was relatively unknown. And then the work that was done that was much better known was the work that was done at United Airlines in the late 60s by a couple of scientists there named Nolan and Heap that came up with this concept of reliability centered maintenance. They were not aware of the work Waddington did because it was still classified at the time, but they basically, reinvented what the Waddington group had discovered and took it sort of to the next level, and that became the basis of how airline maintenance is done in the airline industry to this day.
Gennaro is just wondering, in the scenario where an IA has given an owner a list of discrepancies to the owner, and the owner gives it to another mechanic who does the repairs, how do you know that the owner gave the entire list to the mechanic if you're the mechanic having to do the work?
You don't know, and and the mechanic doesn't have to know. If an annual is signed off with discrepancies, it's the owner's job to make the airplane airworthy again. It's not a mechanic's job to make it airworthy. It's an owner's job to make it airworthy. The owner can use whoever he wants to help him make it airworthy. He can say, well, these 5 discrepancies I want mechanic A to fix, and these other 5 discrepancies I want mechanic B to fix. And mechanic A and mechanic B have no responsibility for the airworthiness of the aircraft. All they have responsibility for is fixing the things that the owner asks them to fix, because the responsibility for the airworthiness lies with the aircraft owner, not with the mechanic. The only time mechanics ever get involved in the airworthiness of an aircraft is if they're an IA and it happens once a year at annual inspection. And at that point, the aircraft owner is required by regulation to hire an IA to make an airworthiness determination on the aircraft. The other 364 days of the year, airworthiness is up to the aircraft owner, not to any mechanic. So there is no way for a mechanic to know that what the entire discrepancy list is if the aircraft owner doesn't want him to, and there's no reason that the mechanic needs to know, because the mechanic is not being asked to make the aircraft airworthy. The owner is being asked to make the aircraft airworthy.
Bill's wondering, there seems to be a real reluctance for one A&P that finds a significant problem to document the problem they found or to advise the FAA of the problem with associated documentation, pictures, log entries, etc. Is this just reluctance within that community to be critical of another?
I'm not really sure I got that, Tim. Is he talking about the reluctance of one mechanic to report another mechanic to the FAA, something like that? Is that what he was asking about, you think?
It seems like that's the context of his question.
Well, nobody wants to report anybody to the FAA. I mean, that doesn't strike me as being surprising. I'm not sure I have anything profound to say about it, except that it strikes me as basic human nature.
Okay, Albert.
Owners always want to report mechanics to the FAA because they get angry at them. But, mechanics tend to not want to report other mechanics to the FAA or any more than doctors want to get other doctors in trouble. They just don't like to do that.
Albert says then, as a renter, what should I do to ensure the right maintenance is done on the fleet I fly?
Well, that's difficult. I mean, the best thing you can do is, first of all, to ask to review the maintenance records of the aircraft, which you certainly are entitled to do, and possibly visit the shop that is doing most of the maintenance on the aircraft, just to get, a feeling for, whether you get a warm, glowy feeling when you visit that shop. There isn't much more you can do than that.
Jill wonders, have you observed any gender differences in pilots' attitudes towards maintenance and AME relationships with pilots?
Um, I'm not sure how to answer that. Most of the aircraft owners that I know are males. The ones that I know that are females tend to be real firecrackers, though, not particularly bashful. So I'm not sure that I can say that there are any gender differences.
Okay.
And there's certainly a difference in population by gender, but I'm not sure about a difference in attitude by gender.
Okay, Keith is wondering if you could discuss giving your logbooks to the mechanics and getting them back from the mechanic.
Well, we counsel our clients never to give logbooks to any mechanic under any circumstances, or to anybody under any circumstances, with the sole exception being the one case where you're required by regulation to do that, and that's when you sell the airplane. When you sell the airplane, you're required by regulation to give the logbooks to the new owner, and you certainly should do that. But there's no reason that any mechanic ever needs access to your original logbooks. Anything a mechanic needs the logbooks for, they can do with a photocopy of the logbook. So we recommend that our owners scan their logbooks into a PDF file, and make the PDF available to anybody who is working on the airplane, and require that all maintenance record entries be made on self-adhesive stickers, and that they keep the original maintenance records in their sole control and custody at all times. That's even true if the FAA asks to see the maintenance records. There's no reason an FAA inspector needs the originals. He can do perfectly fine with a copy, and we've done that on a number of occasions where there was some sort of a alleged violation. The FAA wanted to see maintenance records, and we provided them with copies, and they were happy with that. There are a lot of reasons for this recommendation. Mechanics frequently write inappropriate things in logbooks, things that aren't required by regulation to go into logbooks, and things that could devalue the aircraft when it's sold. If the mechanic gets to write in the logbook, then you're stuck with whatever he puts there. If the mechanic makes his logbook entries on a self-adhesive sticker and you don't like what it says, you can hand it back to him and say, I don't like this logbook entry, do it again. And don't say that. Don't say XYZ. It's not required by regulation. You shouldn't have said it. We've also seen quite a few cases where owners and mechanics get into some dispute. Usually it's over an invoice, and the mechanic holds the logbooks hostage as a way of leveraging the owner into paying the invoice. Really easy way to not let a mechanic hold logbooks hostage is not to give them the logbooks. And so that's another reason that we recommend never giving mechanics logbooks. But there's no good reason that they need them. They can do everything they need to do with a copy, and they can do everything they're required to do with respect to maintenance record entries on self-adhesive stickers. So that's what we recommend doing.
All right, Mike. Well, we've gotten to the end of our time here. Let's wrap it up. What a great Q&A session. Thank you, everybody, for such fantastic questions. I saw over 1,000 people, probably 1,050 at least on board tonight. So please, Mike, take a moment, share closing thoughts with everybody.
That's great. I'm glad my iPhone hotspot made it through. It did a little bit better than the hotel internet connection. Well, in any case, just wanted to remind you that if you haven't read my 4 books, they're all available on Amazon or at the EAA bookstore. And in fact, the EAA bookstore is running a special on them. I'm not sure if it's still on or not. If you have read my books, I'd sure appreciate it if you would take the time to post a review. I've been working on turning them into audiobooks. The first book, Manifesto, is an audiobook. It's available on Audible now, and I'm working on the engines book right now. And finally, next 3 first Wednesday of the month webinars that I will be doing. May webinar entitled Annual Deadlock will be what I think is it's a terrible story, but one where there's a lot to be learned from an aircraft owner who got into a deadlock situation with an IA with his aircraft in the middle of an annual inspection. And we'll talk about that and some of the lessons learned from his predicament. The June webinar entitled "What Airplane Should I Buy?" The title I think is self-explanatory, but we deal with a lot of first-time aircraft owners who are looking to buy an aircraft because our company does a lot of pre-buys and stuff. And so I wanted to talk a little bit about guidance on deciding what kind of airplane to buy as your first airplane. And finally, the July webinar entitled "The Great Beyond TBO." We'll be talking about my own personal experiences and personal experiences of some friends of mine in operating their engines very, very far beyond TBO, and what we've learned from that experience. So that's it, and I look forward to seeing all of you hopefully next month.
Well, thank you very much, Mike. It was another wonderful presentation and question and answer session. And to everybody who tuned in tonight, thank you so much for joining us. Have a wonderful evening, everyone.
Thanks, everybody. Bye-bye.